All right, so for today's lesson, we are going to factor trinomials in the form of x squared plus bx plus c. And the do now is basically, can you think of two numbers that multiply to positive 5, but at the same time they add to positive 6? And you need to realize that if you're multiplying to a positive value, your signs must be the same. And if you're adding to a positive value, both same signs better be positive. So a positive 5 and a positive 1 multiply to 5, but add to 6. When you want it to multiply to negative 6, your signs have to be different, right? When we're multiplying to a negative 6, the signs have to be different. If they're going to add to a negative 1, the bigger the two numbers better be negative. So essentially, you're looking for a negative value and a positive value. And the ones that will do that would be negative 3 and positive 2, because that multiplies to negative 6. It adds to negative 1. Multiply to a positive value again, but add to a negative. Signs have to be the same, and both same sign numbers have to be negative. Well, things that multiply to negative 2, that add to negative 3, negative 2 and negative 1. Multiply to a negative 5, signs have to be different. At the same time, add to a positive 4. In this case, the bigger number has to be positive. So if I take a look at positive 5 and negative 1, that multiplies to negative 5, but adds to positive 4. So this kind of game is the one that you play when you try to factor trinomials. What you want to be able to do is find two numbers that add to the coefficient of the middle term and at the same time multiply to the coefficient of the last term. This is something that we call IAM, and the idea is IAM is spelled like I-A-M, I being I have to, or Roman numeral 1, but I have to what? I have to add two numbers that'll equal the coefficient of the middle term, and at the same time, I have to find two numbers that multiply to be the last term, or the coefficient of the last term. Okay, so I have to add to the middle number and multiply to the last number. So when we try to factor, we say, all right, I have to add and multiply. I have to add and I have to multiply. I'm adding to a positive 5. I'm multiplying to a positive 6. My signs both have to be the same and they're both positive. What numbers do that? And hopefully you realize that 3 and 2, both positives, do that. So how do you break up the factoring? Well, the idea is that you want to give yourself two parentheses, because if we multiply two binomials together, we end with a trinomial. And what happens is the only way for the x squared, the I part, to break up is to multiply x times itself. The rest of the problem gets filled in with the numbers that you just figured out that added to 5 and multiplied to 6. And that was positive 3 and positive 2. So this answer right here, parentheses x plus 3 and x plus 2, is the factored form of what they gave you. Let's try it again. It looks the same, x squared plus 5x, but now you're minus 6. So again, when we play IAM, we now have to add to be a positive 5. We now have to multiply to be a negative 6. Well, hopefully you realize that multiplying to a negative, signs have to be different. But adding to a positive, the bigger of the two must be positive. It's not 3 and 2 this time. This time it's 6 and negative 1. 6 and negative 1, because that adds to positive 5 and multiplies to negative 6. So when you open up your parentheses, it's always going to be x and x in the first term, and what gets dumped in next, it's going to be a positive 6 and a negative 1. And again, it doesn't matter which order you do it, but just as long as you've got the same parentheses. Play IAM again. Still have the same kind of numbers, but now you're adding to be negative 5, and you're multiplying to be positive 6. Numbers have to be the same because they multiply to a positive. Because they add to a negative, both same signs have to be negative, and it's negative 3 and negative 2. That multiplies to positive 6. That adds to negative 5. And when you do your parentheses, one of them has the x with the negative 3. The other one has the x and the minus 2. Last but not least, for your IAM, we need to find two numbers that add to negative 5, that multiply to negative 6. signs have to be different because we're multiplying to a negative. It's not 3 and 2 this time. It goes back to the 6 and the 1. Negative 6 and 1. Negative 6 and 1. So when I want to go factored form, 2 parentheses, one parenthesis has an x with the negative 6. The other one has the x and the positive 1. So it's interesting to kind of see these four together because we're dealing with the same middle numbers and the same last numbers, the 5 and the 6, but with the differences of the signs, the pluses or the minuses, means the factors are all different. Let's keep on going. So number 9 becomes x squared minus 6x minus 27. So again, if we think about IAM, we've got to find two numbers that add to a negative 6 at the same time multiplied to a negative 27. Signs have to be different. Bigger sign has to be negative. So negative 9 and positive 3. Right, that's going to add to negative 6, multiply to negative 27. Your factored form, and I'm just going to kind of change it up a little bit. I'm going to put the plus 3 first this time and the minus 9 second. Doesn't matter. It's a commutative property which allows you to move the parentheses around. Next problem looks similar. We're ending with that 27 to multiply to, but it's positive. And now what's happening is we're adding to a negative 12. So we're finding two numbers that multiply to positive 27, but add to negative 12. Signs are both the same, but now they're both going to be negative. And what happens here, it's a negative 9 and a negative 3. There's your sum of negative 12. There's your product of positive 27. And your answer now becomes x minus 3, x minus 9. If we keep going, I'm going to stop writing IAM, but I know that I'm looking for two numbers that add to 6. Same two numbers multiplied to negative 27. Signs have to be different. I'm going to do a positive 9 and a negative 3 because that's what gives me those numbers that I need. So one parenthesis has the positive 9, the other parenthesis has the negative 3. Now we're going to add to a 12. We're going to multiply to a positive 27. We're adding to a positive number. Signs are the same. Sorry, we're multiplying to a positive number. Signs are the same. We're adding to a positive number, so those same signs are both positive. 9 and 3 is what does it. And now we've got x plus 9, x plus 3. Remember, any one of these can be checked by multiplying back out. We haven't done that yet, but I'll show you a quick one. So if I wanted to check this final answer, all I'd have to do is multiply, and I'd say, okay, well, x times x is x squared, x times 3 is 3x, 9 times x is 9x, 9 times 3 is 27, x squared plus 12x plus 27. So you should be able to multiply your answers back and know whether or not you are correct, because your multiplied back answer should be the problem that you started out with. If we IM this one, we want to add to equal a negative 1. Remember, the coefficient of minus y is negative 1. We want to multiply to equal negative 30. It multiplies to a negative. Signs are opposite. Negative 6 and 5. That's what's going to add to my negative 1. That's what's going to multiply to negative 30. So my two factors, x plus 5, x minus 6. In this case, we're going to add to be negative 18. We're going to multiply to be 81. I multiply to a positive, signs are the same, but because I add to negative, both signs are negative. I've got negative 9s, a pair of them, which means the answer is x minus 9, x minus 9. Which expression's a factor of x squared plus 2x minus 15? A factor is which one's a parenthesis? I'm going to actually just kind of work it out. And I know that I have to add to 2. I have to multiply to negative 15. Signs are different. I'm going to do a positive 5 and a negative 3, a positive 5 and a negative 3, which means my factors, my two parentheses, are x plus 5, x minus 3. Oh, found it, x minus 3. These wouldn't make any sense. Which is a factor of x squared plus 5x plus minus 24? We're adding to 5. We're multiplying to negative 24. Signs are opposite. I'm going to go here for 8 and a negative 3, 8 and a negative 3. So one factor is x plus 8. One factor is x minus 3. No, 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 and here it is. Okay. The last thing I want to do is on the homework sheet. We don't have any examples of, actually, let's do number 5 on the next page, which is the homework sheet. So number 5, it's saying to factor, and if the polynomial is not factorable, write prime. And basically what that means is if you can't find two numbers doing what you want it to do. So if I take a look at, and I'll tell you 5 happens to be one of them, but if I take a look at number 5, this is on the homework sheet, I'm looking for two numbers that are going to add to negative 14, and those same two numbers have to multiply to negative 48. Well, as I start going through my list of numbers, 8 and 6 are the ones that I'm really going to want to work with to see if I can get them to work. But if I take the numbers 8 and 6, because that's where I see 14, my signs have to be different. If I make the 8 negative, my sum is negative 2. If I make the 6 negative, my sum is positive 2. There's no way to get this 14 to come out. So this doesn't work. And this we would call prime. The next one I would like for us to do, and then we'll stop, is the factor completely problems, where it says to find the GCF first, and then you factor again using IAM. So if we take a look at number 11, I can't IAM right now because I don't have a 1 in front of my y squared term. I've got a 5. But I realize that I can divide everything through by 5. So I really have a GCF of a 5, and what's left over is y squared minus 8y minus 20, because 5 times y squared is 5y squared. 5 times negative 8y, negative 40y. 5 times negative 20 is positive 100. But what you have to understand that is what's left over inside the parentheses is in fact something that you can IAM, because I sure can find two numbers that add to negative 8. I can also find two numbers at the same time that multiply to negative 20. Those numbers would actually be a negative 10 and a 2. So when I actually factor a second time, my GCF I cannot lose. But then that polynomial factors into what we just did. It becomes y minus 10 and y plus 2. So this has a GCF from the other day outside the two polynomials from the IAM. All right, so that should be enough to get through the homework. Good luck.